In this video, we're going to look at the angle between two vectors. So we're being asked to find the values of x so that the vectors 2, 1, negative 1 and 1, x, 0 is 45 degrees. Alright, so we remember that we have a formula that gives us the angle between two vectors that's in terms of the dot product and the magnitude of the two vectors. So the cosine of the angle between two vectors is equal to the dot product of the two vectors divided by the product of the magnitudes of the two vectors, as long as one of them is not, neither of them are the zero vector. If one of them is a zero vector, we'll get a 0 in our denominator here, which we do not want. All right, now this is just a matter of solving an equation. We've got everything plugged into the formula. We just need to start solving here. Cosine of 45 degrees is root 2 over 2. Dot product here is 2 plus x on top. Magnitude of the first vector, 2 squared plus 1 squared plus negative 1 squared is 6, so we get square root of 6 for the first one. And then we get square root of 1 plus x squared for the second one. I'm not excited about these radicals, so I'll square both sides, giving me 1/2 equals 2 plus x quantity squared over 6 times 1 plus x squared. Let's do some cross multiplying here a little bit. Actually, I'm not going to cross multiply. I'm just going to clear this denominator over. The 6 and the 2 will go into the 6 3 times, so I get a 3 plus 3x squared on the left-hand side. Multiplying out the right-hand side gives me 4 plus 4x plus x squared. Got a quadratic to solve here, so we'll move everything over to the left-hand side. Unfortunately, that does not factor, so we'll use the quadratic formula. Negative b would be 4, plus or minus b squared, 16, minus 4 times a times c. So I get minus 4 times 2 times negative 1 gives me a plus 8, and then all over 2 times a, so that's where the 4 comes from. 4 over 4 is 1. This is square root of 24, which is 2 root 6. So you'll get root 6 over 2 for the second part. So there's our two values of x that will satisfy this.